been a minute since we've taken notes together here in class, but here we go. Yep, lowercase m. Beautiful. Looks great. So, give me a thumbs up if you've ever heard the term slope before.
I played the game.
There's a game called Slope?
Yeah.
Oh. Well, in any form. I'm talking not about just in math, just the word slope before. Where have you heard this? I can't even talk. Have you heard the word slope before? Yeah? Okay. Can someone tell me where you may have heard the word slope besides the game Slope? Oh, everyone knows it from the game Slope. Brazon?
I know. Like, it sounds like steep and like going down.
Steep and you're going down, like skiing, right? If you're skiing the slopes, that means you're going down the slopes, right? Kenny, where have you heard slope before?
People work on them.
People work on slopes? Okay, yeah, for sure. I mean, if you work at like a ski resort, you could work on a slope. Definitely, yeah, absolutely. So basically, slope means exactly what Brazon and Kenny said it means. It's like an angled elevation, in a way. Don't worry about too much what we'll get to it, don't worry. So the definition of slope is going to be the ratio between our change in y value and our change in x value. We'll see what those two things mean in a second, but just know for slope, we use the variable m. What was our constant of proportionality variable again? K, right? So now we're not using K anymore. We're using M because what we're doing is very similar, but it's a little bit different. So let's take a look. Yeah. So if we've got y over x, okay, we can call that rise over run.
That triangle.
It is a triangle next to the y and next to the x. Okay, and there's a little graph just for us to visualize this. So you're going to hear me, yes? Yeah, go ahead. So you're going to hear me say this phrase rise over run a lot with this unit. When we're talking about rise, right, we're speaking only on the y-axis. That's why in that little graph I wrote y rise, okay? You can also remember that because they both have long I sounds, right? Y, rise. They kind of rhyme. So think about that. Run is going to be our x-axis, right? So we can think of it like if you're rising up, right, you're going vertically. That's going to be our y. And if you're running, you'd be running horizontally, right, in a straight line. So that's going to be our x-axis, okay? So this is how we're going to find our slope. We're going to find the change in y and the change in x, and we're going to divide them. Looks very similar to our k equals y over x, right? So let's learn what a slope triangle is. Oh, also, sorry. These little triangles here, those are just the way in math we write the word change in. So whenever you see a triangle like this next to a letter, that means the change in x or the change in y. Go ahead and write this example real quick, then we'll talk about it. Ooh. Go ahead and draw a little graph. Oh, you can't even see that. Go ahead and draw a little graph for example A. It doesn't have to be perfect. Just try and make it as close to perfect as possible, but it's okay if it's not perfect. And then go ahead and label your axes too, with a y and with an x. Then I want you to make 2 points on this graph. One at the point 1, 2. And one at, let's go 4, 5. Maybe that'll work. Yeah, let's do 4, 5. You should all have mini rulers in your group's supply box. So go ahead and give everyone a little ruler. Might make drawing our graphs a little easier. Dang it. Yeah.
You always have to write the change in y every time you write the formula.
No. I'll show, once we get to other examples, I'll show you what your work is going to look like. When we're starting out, though, I always kind of make it extra just because it helps. Yeah.
Can I use the bathroom? No.
Okay. She had her hand up, so she can go. When she comes back, you can go. Go ahead, Scott. It's okay. We got plenty of time. We still got 45 minutes of class. Have fun.
You didn't sound too happy.
That's okay. So, I'm excited. So we got these 2 points here, 1, 2, 4, 5. Hopefully your graph looks something like this. It's okay if it's a little bit wonky. I told you about the rulers late, so that was my bad. But having these points here is what matters. So now what we're going to do is we're going to try and find the change in y and the change in x. Now what does that mean? Let's take a look. What's our x coordinate from our first point down here, the one I'm pointing at? What's our x coordinate there? Our x coordinate is 1. What's our x coordinate for our second point? 4, right? So our x coordinate went from 1 to 4. What did we change, or by how much did we change that x value?
3.
By 3, right? If we're counting up our run, right? This space on the x-axis between these 2 points is 3. 3 spaces from 1 to 4. Change in y is just how far apart our 2 points are on the y-axis. So here, our first point, we have a y value of what? 2. And then we have a y value of what on our second point? 5. So we went from 2 to 5, which is a change of how many? 3, right? 3. So our rise, our change in y that we found by just counting up, literally just drawing a dotted line and counting up, that gave us a rise value of 3. And then our run, we ran over to the right 3 spaces, so our run value is 3 as well. What does 3 over 3 simplify to?
1.
Just 1. And that's our answer. We found our very first slope. So in Math 7, you guys didn't learn how to find the slope of any line or anything like that? No? Beautiful. Perfect.
She was so just.
She was on 18%.
She was just so. She had to do like 2 IXL today, and then like worksheet.
Get my stamp too. Why didn't I finish with a C?
I finished with a D. Anyway, babe.
All right. For example B, I used my graph stamp just so we could actually see a little bit better.
What the heck? How did you?
Just a stamp.
Oh.
Okay? I would come stamp all your papers, but that would take about 30 minutes, so we're not going to do that. So again, just try and draw as best of a graph as you can.
That's so.
So I want your point A, we'll call it, and point B. Let's say A is at a 3, 3. There's point A. And then point B is going to be at -4, -2. So go ahead and draw those 2 points. You're going to want to draw a full graph, not just the little half graph like we did with example A. Just try your best. I know it's hard.
I messed that up.
I'll just give you guys little cutouts of graph paper. You can glue it, because you all have glue at your desk. But I'll do it tomorrow. I didn't prepare it.
Graph paper to put it in our notebook.
Yeah, like if I give you a little cutout of graph paper that you can glue in and draw your graph.
First
Actually
one
has
should be
grids.
three.
You know?
Are you putting some grid?
Yeah, of course.
B. Is it -4? Third.
So you don't have to draw it with like as a whole box. You can just do it like this.
I literally just did that. You have to erase it today. Erase it all.
It's a little too late.
So just draw your graph like this. You don't need to go with the full-on grid. You can just draw it like that and you should be fine. I know it's a lot easier with the grid. Tomorrow we'll have graph paper, don't worry. I'll get it ready. All right, so with this line, let's go ahead and, I forgot to connect my line even.
You have to connect from one.
Of course, so we know it's a line.
Is it?
Literally, he said I have to.
Real quick, is this line, or is this graph a proportional relationship?
No.
No, I hear a lot of no's. Why do you say no? Who can tell me?
It's not going through the origin.
Okay, thank you, Jordan. Can someone give me a quiet hand and tell me why this is not proportional? Sorry. I want to give everyone a chance to talk. I don't want... All right, never mind. Thank you, Jordan. I appreciate that. No, this is not proportional because we are not going through the origin, right? But that's completely fine because we're not talking about proportionality and the constant of proportionality right now. This is the next step in our progression of this unit. All right, let's go ahead and find our rise over run. So when we have a graph, we'll talk about tables next, but when we have a graph, it's going to be really easy for you to just draw your change in y and your change in x directly onto your graph. That's the reason why we don't have an IXL. It's because it would be impossible or really hard to do because you can't draw on your screen. So we're going to start at our far left point, and we're going to travel up and over until we hit our second point. So let's travel up first. Let's see how many spaces this is. 1, 2, 3, 4, 5 spaces up. That's our rise, is 5. Question back there again, fellas? That's okay. So we rose up 5, and then we're going to run over 1, 2, 3, 4, 5, 6, 7. Change in y over change in x gives us our answer. M equals 5 over 7. That's our answer. We can't simplify that anymore. And just like with our k values, it's totally fine if we have a slope that's a fraction. It's actually better for us because when we're doing rise over run, When we have a fraction, we know that our top number is our rise and our bottom number is our run. If we turn this fraction into a decimal, now we don't have a clearly defined rise and run. You would have to convert it back into a fraction, which is why I told you guys not to worry about decimals. Keep it as a fraction, because a fraction is two steps. The rise is your numerator, and the run is your denominator. Okay? Questions on this? I know it's kind of a lot all at once, but what can I help you guys with here? Okay, that's all right. Let's go ahead and take a look at example C. Now let's look at a table and see what we're going to do with that. Yeah. Say that one more time.
We can barely see it.
Oh, sorry about that. My bad.
Yes, sir.
All right. So with a table, it's a little bit less visual than a graph. Okay, we can't just count how many spaces we go up and then count how many spaces we go over. And I want to make it really clear here that we're not doing what we did yesterday. We're not just sticking a y value over an x value and calling it a day. Okay? Because as you can see, 10 over negative 3 isn't going to equal 6 over negative 1 or 2 over 1. Yes, Theo? Okay. Yes. Okay. So here's what we're going to do. We're going to find our change in y. We can't rise up physically, but we can see that our y values change as we go down this table, right? So let's take a look at our first two y values, 10 and 6. And we're going to ask ourselves, how do you get from 10 to 6? How do you get from 10 to 6? What do you have to do?
Subtract.
Subtract how much?
4.
Subtract 4. That's not the answer just yet. It's only half the answer. We're just finding our rise right now. So from 10 to 6, our change in y was minus 4. What's our change in y from 6 to 2? How do we get from 6 to 2?
Negative 4.
Subtract 4, right?
Yeah.
How do we get from positive 2 to negative 2?
Subtract 4.
Subtract 4 again. Look at that.
Hooray.
This shows us we have a constant change in y. Okay, our change in y is equal to negative 4. Step 2 is going to be to find our run, or our change in x. So now we're going to do the exact same thing. Yeah, Brandon. When whoever just left comes back. Did someone just leave? I'm tripping. Okay, go ahead and go. All right, how do we get from -3 to -1? What do we do to -3 to get us to -1? Actually, forget about that. How do we get from +1 to +3? What do we add to 1 to get 3? Noah?
Add 2.
We're adding 2, right? From 1 to 3 is a change of +2. From -1 to +1, that's also +2. And so is from -3 to -1. Okay, so to get from -3 to -1, all we're doing is adding 2. So our change in x is 2. Step 3 is plug in and simplify. We know that m is equal to the change in y over the change in x. Our change in y was equal to what again? -4. And then our change in x was 2. -4 over +2 simplifies to be what? What's 4 divided by 2?
-4 divided by 2 or just 4 divided by 2?
Just 4 divided by 2 would be 2. And then a negative over a positive would give us a negative, right? So our slope here is -2. Or m equals -2. Yeah. Yes. Yeah. Dang it. Yeah. Zoom out, you said?
Yeah, to where the table is shown.
Yeah. Yeah, go ahead. Oh, dang it.
Oh, we used 30 minutes of notes.
I know, right? Almost done, don't worry. So we got one last thing. Go ahead and draw 2 little plus graphs. You don't need notches on them or anything like that. Okay, anyone still writing example C?
No.
All right. Oh, okay. I'll give you a second.
Or under.
Perfect. So here's what I want you to do. I want you to draw two lines. The first one is going to look exactly like this. And the second one's going to look exactly like that. What's different about these two graphs? Is there anything different about these two graphs?
No.
Yeah.
Not really.
What's that, Brandon? The line across? What about the line across? It's facing different ways. Very good observation. These two lines look like they're going in different directions, right? So this left graph represents a line with a positive slope. The graph on the right represents a line with a negative slope.
Mr. Church,
What's up?
you don't know who made this little gremlin thing?
No.
It's that girl over there.
Okay. Let's take a seat real quick. We're almost done with those, buddy. Okay, I'm going to stop moving it around now. Steady. So as you'll see, or as we saw in example C, we found a slope of -2, right? And that's completely fine. We can have a negative slope. It just changes the direction that our graph is slanted. So if you ever forget, all you have to do is ask yourself, from left to right, is this line angled up or is it angled down? So let's take a look at this first line. From left to right, are we angled up or are we angled down?
Up.
In the first example, are we angled up or down, everybody? We're angled up, right? Imagine you're standing on the leftmost end of this line. Okay, there's the little stick figure. Imagine that's you. And you start on the left, just like when you read a book. You start on the left and you go to the right. If I told you to get to the end of this line, would you be walking uphill or downhill? You'd be walking uphill, right? Uphill equals positive slope. Now, if you were standing on the leftmost end of this line, and I told you to get to the other end of the line, would you be walking downhill or uphill? Downhill, right? If from left to right you're walking downhill, you have a negative slope. Okay? So the reason why this is important is because when you're doing your rise and run with your graphs, okay, on worksheet 13, you got a bunch of graphs on the front. When you're doing your rise over run, don't worry about whether you're going in a negative direction or a positive direction. Just count the spaces and then look at your graph as a whole and ask yourself, am I sloping uphill or downhill, okay? And we'll see what I'm talking about in just a second when we get our worksheet.